to like a cubic function. Okay, so it's something. I'm not going to pick specific numbers because I don't know what they would be, but ax cubed plus bx squared plus cx plus d. It's some cubic function, right? Now I can talk about limits at infinity when x goes to infinity or negative infinity. So if I hop on this graph and I start out, say here, somewhere in the middle of the graph, and I follow to the right as x gets larger and larger, x goes to infinity. So I follow that down. If you think about what a cubic function looks like, if you can visualize, I mean, I've drawn one roughly, but if if you're familiar with what cubic functions look like, then this is going to go to negative infinity, right? Negative infinity is you follow this way to plus infinity, you're going to go down this way to negative infinity. So the limit as x goes to infinity of f of x is negative infinity, okay? And of course, infinity is not a number, but we're indicating the behavior of the graph. And that's what limits are about. What is the behavior of the graph? So it's totally fine to use infinity in this context. On the other side, change colors here. I start out like right here, and I follow this up, right? Well, then as x goes to negative infinity, as I follow x to negative infinity out to the left, just follow the graph is going up to positive infinity. So I can say that the limit as x goes to negative infinity of f of x equals infinity. Okay. Now, there's an uncommon error. There's really two facets to it. So some people will look at this, and it's just an error, but that's bound to happen when you're learning something new. And this concept here called end behavior probably isn't new to you. You've seen this in algebra most likely. What's the end behavior of the graph, right? This is essentially limits at infinity is what end behavior is. Some people will look at this, go, oh, infinity over here in the purple and negative infinity over here in the blue. Oh, that means the limit doesn't exist because they're different. So these are not one-sided limits, really. These are just limits. These are infinite limits. X is going to infinity or minus infinity. And so if you were a math major or a physics major, then later you might deal with something called the extended real numbers, but that's a year from now, minimum, I would think. And that's if you're majoring in something that does this. So infinity can be treated like a number in certain contexts to do certain calculations, physics and math specifically. Maybe chemistry, potentially. I'm not totally sure about that. Anyway, these are not one-side limits. These are just limits at infinity. So there's no need to compare this one with this one. They're not comparable. They're on totally opposite sides of the graph, right? The one in purple, this follows the graph out to the left. The one in blue, this follows the graph out to the right. They're in totally opposite directions. There's no sense in comparing them. I mean, you could say they're different, but that's not really it's not really a useful comparison, I don't think. So don't think like, oh, they're different, therefore something doesn't exist. So in particular, this is sort of a notation thing. Oh, and I'll point out I am going to go over about 10 minutes or so. So we have a few more minutes because we had that gap where my internet dropped out. But we'll wrap up this example. We're almost done here. If I have a number line, right, and I have 2, and I approach 2 from the left, I can say, oh, I can say that x goes to 2 from the left. And if I approach 2 from the right, if I approach to the right, I can say, oh, well, x goes to 2 from the right. If I go to infinity, I can say, oh, x goes to negative infinity on the left. And if I go over here to the right, I can say, oh, well, x is going to positive infinity. What you can't do is you can't have, oh, x goes to infinity from the right. How do you approach from the right to go to infinity? There's infinity is all the way on the right end of the number line. It represents all the way at the end. And there is no end, right? There's infinitely many numbers, but infinity is like the bookend. It encapsulates the right hand side of the number line, and negative infinity is the bookend on the left, right? I can say negative infinity is all the way at the end here, and positive infinity is all the way at the end here. How do you come at infinity from the right? You can't. It's all the way at the right. It's the end cap. You can't approach from the other side, right? And then how would you say, oh, x is going to go to negative infinity from the left? Well, how do you come at it from the left? There's nothing over there, right? So both of these are sort of nonsensical. You can't do that. That's not how the number line works. If you wanted to write x goes to infinity from the left, okay, but everything is to the left of infinity on a number line. So it's sort of redundant. I suppose it's not incorrect. It's just weird to write that. So don't do that. And then also x goes to negative infinity from the right. Well, yeah, everything is to the right of negative infinity. That's the only way to approach it. So sort of redundant. So don't write that either. These are basically the options. Of course, 2 is not the only number we can deal with, but these are the 4 kinds of limits.